Okay, this is the video on the questions and answers with respect to electrolysis. So let's see the first question. The first question says the diagram shows apparatus used to electroplate a metal ring with copper. So he's trying to cover the metal ring with copper. The experiment did not work. So which change is needed in the experiment to make it work? Well, the first thing is, if he says A adds solid copper sulfate, that's not a good idea because the solid would not conduct electricity. We need it aqueous. If he says increase the temperature, okay, temperature has nothing to do with electrolysis. We're not heating this to cover it with silver or with copper or with whatever. Replace the copper electrode with a carbon electrode. No, we need the copper electrode if we're going to cover the metal ring with copper. Now reverse the connections. Yes, we need the copper, the ring, the metal ring, the object that we're trying to electroplate. We need it to be at the negative electrode so that the copper ions can go to it, and copper ions are positive. So the answer here is D. 3 electrolysis cells are set up. Each cell has inert electrodes. The electrolytes are listed below. In which of these cells is a gas formed at both electrodes? So let's take a look at each one. Now, the first one is aqueous sodium chloride. Now, if we're doing aqueous sodium chloride, let's try and remember what happens at the anode and what happens at the cathode. Well, sodium chloride has these ions because it has water in it, so it has H plus and OH minus. Now, if he does not specify whether it is aqueous, whether it's concentrated or dilute, here it wouldn't make any difference anyway. So at the anode, you will either get chlorine gas if it is concentrated, or you would get oxygen gas if it were dilute. At the cathode, we said if we have a choice between Na plus and H plus, it is the H plus that happens. So this will give H plus that reacts. So this will give gases at both electrodes. What about dilute sulfuric acid? If we're doing dilute sulfuric acid, now what do we get at the anode? We said it's hydroxide that will work, so it will give oxygen. And the other, at the cathode, there is no choice, it is hydrogen. So here also we have a gas at each electrode. Now, molten lead bromide has only lead ions and bromide ions. It's molten. So at the anode, I would get bromine, and at the cathode, I would get lead. So this is not something that will give a gas at both electrodes. So the cells that give a gas at both electrodes are 1 and 2. So my answer is A. The following electrolysis circuit is set up using inert electrodes. At which electrode is a metal deposited? Remember that you get a metal only if the electrolyte is molten. If we have concentrated aqueous sodium chloride, are we likely to get a metal? We're not, because at the positive we will have chlorine, and at the negative it is the hydrogen that will react, not the sodium. So we don't get a metal in here. But when we do molten lead bromide, then we will have bromine at the positive and lead at the negative. So this is the electrode where a metal will be deposited. In which electrolysis are chlorine, hydrogen, and sodium hydroxide all produced? Well, let us take a look at this. Sodium chloride. Sodium chloride aqueous will have these ions. So what will happen at the anode? At the anode you will have chlorine, and at the cathode it will produce hydrogen. And what happens is the chloride ions has reacted and the H plus ions has reacted, and we end up with Na plus and OH minus. So this is something that will give chlorine, hydrogen, and sodium hydroxide. So our answer is A or B. Now, molten sodium chloride will give chlorine at the anode and sodium at the cathode, but there is no way that we're going to get either hydrogen or sodium hydroxide. So the answer is B. Okay, concentrated aqueous potassium bromide solution is electrolyzed using inert electrodes, and he gives the ions. To which electrodes are the ions attracted? You have to remember, anode has what kind of charge? It's positive, so it will attract what? It will attract negative. So actually, the only answer possible is B. The cathode also is negative, so it attracts the positive ions. What is the charge on an anode and the type of element formed at such an electrode? Okay, the charge on the anode is what again? The anode is the one to which the anions go to. Anions are negative, so it must be positive. So the anode is the positive. Which element will be likely to go to the positive? It's something that is negatively charged, and the ones that are negatively charged are non-metals. So it is the non-metal that goes to the anode. Metal X is low in reactivity series, and it is liberated by electrolysis of its bromide. We haven't talked about reactivity series in detail, but we've said that the reactivity series is a list of metals or common metals that are listed according to their reactivity. So he's telling me that metal X is low in the reactivity series, so it's not really reactive, and it is liberated by electrolysis of its bromide. So metal X could be what? Low in reactivity series means not reactive. So is it sodium or lead? Well, sodium is very reactive, so it must be lead. And the bromide is, in order to get the metal, the bromide has to be molten, not solution, because we said when we have these things, it is usually the hydrogen that reacts. Different metals were tested using the apparatus shown. Which pair of metals would produce the largest voltage? Remember that we said this is a cell because we have a voltmeter, not a battery, and that means that the one that will produce the largest voltage is the one that has the biggest difference in reactivity. Again, if we remember the reactivity series, if we compare the reactivity of copper and silver, for example, where's copper and silver? Right at the bottom there. Magnesium and silver is a very big difference. Magnesium and zinc is smaller, and zinc and copper is smaller, so it's actually magnesium and silver. Can you see magnesium? Way up there, and the silver is at the bottom, Ag. Silver is Ag. So this is a big difference in reactivity. Diagram shows the circuit for electrolyzing lead bromide and sodium chloride to liberate the metal. In what form are these salts electrolyzed to liberate the metal? So lead bromide, in order to give lead, it has to be molten. And sodium chloride also, in order to give sodium, it has to be molten. Okay, here we're saying when concentrated sodium chloride solution is electrolyzed, elements X and Y are formed. So what are X and Y? Okay, well, that depends on what we're talking about. What are we talking about? Concentrated sodium chloride. So you should be able to know that concentrated sodium chloride has sodium ions, chloride ions, H plus and OH minus. So which one will go to the negative to form X? Well, the ones that will go to the negative are sodium ions and H plus ions. And we said if we are comparing between the sodium ions and the H plus ions, we said the H plus ion is the one that will always react, so X must be hydrogen. So my answer is B or C. Then at Y, which one reacts at the positive? We said at the positive, the chloride ions and the hydroxide ions will go to the positive, but when we're comparing between chloride and hydroxide ions, we said which one will react? The one present in higher amount. So if this is concentrated, then I have a lot of chloride ions, and that will give chlorine. So my answer is B. Okay? The diagram shows the electrolysis of concentrated aqueous sodium chloride. What is the color of litmus at each electrode after 5 minutes? Okay, let's take a look at this. What are we doing? We're doing concentrated sodium chloride. That's the one we were just talking about. And we said concentrated sodium chloride will give chlorine at the anode and hydrogen at the cathode. We have talked about the test for chlorine gas. What was the test for chlorine gas? That if I put litmus, it bleaches. Bleaches means that the litmus will become colorless. So actually my answer must be D, Now, the color at the cathode is what is formed at the cathode? Well, at the cathode we said hydrogen. Hydrogen has no effect on litmus, so it's not going to cause litmus to be blue. But what is going to cause litmus to be blue? We said that if the hydrogen gas is formed at the cathode and chlorine gas is formed at the anode, what is left in solution? The chloride ions have reacted, the hydrogen ions have reacted. I'm left in solution with sodium ions and hydroxide ions. That is sodium hydroxide, which is a base, and the base will turn litmus blue, so my answer is D. Okay. Diagram shows an electrolysis experiment using metals X and Y as electrodes. One of the metals becomes coated with copper, so you want something to be coated with copper. Now, you should know that copper ions are positive, so if you want the copper ions to go to one of these, it has to go to the negative. So actually, it should be Y that should be coated. Do we understand that? You want copper ions to go to something to be coated with copper. So that's electrode must be the negative ion. So the copper ions will go to the negative ions and coat Y, metal Y. Then what should be the solution? We said if we are trying to coat something with copper, then the solution should be copper something. When we were trying to electroplate with silver, the solution was silver something. So here it has to be copper chloride, not chromium. We're not trying to coat with chromium. Okay, the diagram shows the electrolysis of molten lead bromide. What is seen at each electrode? Okay, let's think. Molten lead bromide has lead ions and bromide ions. Now, which one is going to the positive? It is the bromide ion, so they will form bromine. Now, what is the color of bromine? You should realize that bromine is brown, not green or silver. So it is brown. Is it a brown metal? It's not a metal. Bromine is not a metal. So my answer must be A. Okay, let's think about Y. Y is the negative electrode. The lead ions, which are positive, will go to the Y, to electrode Y, and deposit there as lead. So that would give me a silvery metal. Okay, which diagram shows an experiment in which the bulb lights up? Basically, the bulb will light up if electricity is passing through. Now, for electricity to pass through, the circuit must be connected to something that conducts electricity. So let's look at A. A is connected to something that is covered with plastic. Will plastic conduct electricity? No, you should realize that plastic is an insulator, so A will not have the bulb light up. Okay, what about B? B has the circuit connected to bitumen. Is bitumen something that conducts electricity? Well, what did we say? To conduct electricity, it has to be an ionic compound. Bitumen is not ionic. Okay, what is C? The electrodes are put in concentrated hydrochloric acid. Yes, hydrochloric acid will conduct electricity because it has positive and negative ions. So C should be my answer. What is D? D is connected to sodium chloride, but these are crystals, and remember, sodium chloride as a solid will not conduct electricity. It's an ionic compound. It will not conduct electricity as a solid. So the answer is C. Okay, do you understand how to choose these answers? You don't just choose randomly. Okay, in which set of apparatus is the metal key electroplated with copper? Again, if I want copper ions to go to the key, then the key has to be which electrode or connected to which end of the battery. Well, the copper ions are positive, so it needs to go to the key, so the key has to be negative. So the key has to be connected to the negative. And we should have aqueous copper sulfate solution that is present in all of them, and we should have a piece of copper that will be at the positive. So the copper ions should be at the positive, the key should be at the negative, so D is the one that will work. Okay, the diagram shown is not complete. What should be shown at X when the solution has been electrolyzed? So he is doing what? Concentrated hydrochloric acid. Again, what will be formed at the positive and at the negative? How do I know which one is positive and negative? Well, we look which one is connected to the do you know the sign of the battery? The battery, when in physics actually, they have the sign for the battery. The long line is for the positive end and the shorter line is for the negative end. So the first electrode on the left is connected to the positive, the electrode on the right is connected to the negative. So again, if we're doing electrolysis of concentrated hydrochloric acid, we have H plus ions and Cl minus ions and OH minus ions. Okay, which one will go to the positive to go to the electrode on the left? Well, we have the positive electrode, chloride ions and hydroxide ions will go to it. Now, which one will react? We said the one present in higher amounts. So here we have concentrated hydrochloric acid. That means we have more chloride. So the electrode on the left should have chlorine. Now on the right, we only have H plus ions anyway, so it will be hydrogen. So my answer B. Okay, so the answer is B. Okay, the diagram shows a method used to electroplate a key with copper. Again, I want to cover the key with copper. So I have a copper foil or a copper acting as an electrode at the positive, and the key is at the negative. Now, which solution is most suitable? We said if I'm trying to electroplate with copper, then the solution should have copper something. So the only one that we have here is A. It must be a solution of copper sulfate. Okay, and remember, it must be copper something that is soluble. So it is copper sulfate, for example, not copper carbonate. We know that copper sulfate is soluble, and we also know that anything nitrate is soluble. So this could also be copper nitrate, but it cannot be something like copper carbonate, which is insoluble. Okay, so this question says the statements refer to the electrolysis of concentrated copper 2 chloride. And he's giving me some statements, and he's saying which statements are what? Which statements are correct? So we're looking for the correct statements. Okay. So the first statement says electrons are transferred from the cathode to the copper 2 ions. Well, let's see. If we have the electrolysis set up, where do electrons move from or to? Now, the copper 2 ions are positive ions, and the positive ions go to what? The positive ions go to the cathode. So they go to the cathode in order to do what? To take electrons. So that statement is correct. Okay. Then the second statement says electrons move around the circuit. The circuit, that means the wire going to the battery and away from the battery. Now, he's saying it moves from the cathode to the anode. Actually, the electrons are attracted to the positive end of the battery and repelled away from the negative end of the battery, and that means that they're actually going towards the cathode, not from the cathode. So that statement is definitely wrong. Then he says chloride ions are attracted to the anode. Well, chloride ions are negative, so they will be attracted to the positive, which is the anode. So that is correct. Okay. Hydroxide ions transfer electrons to the cathode. Hydroxide ions are negative. They will go to which one? They will go to the positive, not to the negative. So that statement is wrong. Which statements about the electrolysis are correct? So we found that 1 and 3 are correct. So my answer is A. Okay. Electricity is passed through concentrated aqueous sodium chloride. Inert electrodes are used. What is formed at the negative electrode? Okay, we have concentrated sodium chloride. Again, concentrated means I have more chloride, so it will go to the positive. But he's asking about the negative. We have a choice between the sodium ions and the H plus ions of the water, and we said when we have this choice, which one do we use? We use hydrogen. So it is the hydrogen that will react, not the Na+. Okay, aqueous copper sulfate is electrolyzed using copper electrodes. What are the ionic half equations for the reactions that occur at each electrode? Okay, we have copper 2+, so the copper 2+ will go to the negative. So it is A or C. The copper 2+ goes to the negative, which is the cathode. And which one will work at the anode? We said at the anode, it is, since we're using copper electrodes, it is the electrode itself that will dissolve and form copper ions. So the answer is A. Okay? Okay, this next question is about hydrogen-oxygen fuel cells. Remember that we said a fuel cell is one in which the reactants are being continuously introduced. One of them is the one that uses the reaction between hydrogen and oxygen to give water. So he's saying these can be used to power cars. Platinum is used as a catalyst. The amount of energy produced is shown. Which statement is correct and is an advantage of a hydrogen-oxygen fuel cell? So basically he's saying, what is the advantage of the hydrogen-oxygen fuel cell? Well, let us take a look. Hydrogen is difficult to store. Anyway, this would not be an advantage. Hydrogen produces less energy. That's not an advantage. Platinum is rare and expensive. Well, that would mean that this process is bad, not good. So that's a disadvantage actually. So the only product is water. That is an advantage of the hydrogen fuel cell. Okay, the diagram shows the electrolysis of molten lithium iodide. Draw an arrow on the diagram. Show the direction of the electron flow in the external circuit. Again, the external circuit is the one that has the wires going to the battery. The wires have electrons in them, electrons in the wires floating. So how will they be moving? They will be moving towards the positive, away from the negative. So that is the direction of flow of the electrons in the external circuit. Okay, electrons are supplied to the external circuit. How and where is this done? So where in the solution are electrons given to the circuit? We know that the negative ions go to which one? The negative ions will go to the positive and give electrons. So that is how the electrons move to the circuit. So negative ions give up electrons at the anode. Okay, explain why solid lithium iodide does not conduct electricity, but when molten, it's a good conductor. Well, we talked about this when we were talking about ionic compounds, and we said ionic compounds do not conduct electricity when solid, except when it is molten. So ions are free to move when molten, but not when solid. Okay, the results of experiments on electrolysis are shown. Complete the table. So he is doing electrolysis of aqueous copper sulfate using inert electrode, platinum. So when we have copper sulfate, so the electrodes are not copper, like purification of copper, the electrodes are just platinum. So what we have in solution is copper ions, sulfate ions, H+ ions, OH- ions. The cathode is the negative, so which one goes to the negative? Either the copper 2+ ions or the H+ ions. And we said if we're comparing between copper 2+ and the H+, actually it is the copper that reacts, so we form copper at the cathode. Now, what is going to form at the anode? Well, he's telling me it's oxygen, and that's because we said the sulfate never reacts, so it is the hydroxide ions that react to give oxygen. Okay, so what happens to the electrolyte? The copper has reacted, the copper ions have reacted, and the hydroxide ions have reacted, and we said that leaves what in solution? It leaves H+ and sulfate ions, so this is sulfuric acid. If we're doing electrolysis of concentrated aqueous potassium chloride, again at the cathode is the negative, which one will react? Potassium ions or H+ ions? Always, if we're comparing between H+ ions and ions of a reactive metal, it is the H+ that will react to form hydrogen gas. Now at the cathode, this is concentrated, so it is the chloride that reacts, and that means what has reacted is the H+ ions from solution and the Cl-, so I'm left with K potassium ions and hydroxide ions, so the solution becomes potassium hydroxide. Okay, electricity was passed through molten lead iodide. Even if he tells me what lead is, lead iodide, the valency of lead is 2, so lead is 2+. A purple gas was observed. What do you think is the purple gas? Well, the purple gas, it must be iodide reacting to form iodine, because iodine as a gas, it is purple. Okay, first of all, what piece of apparatus is missing from the diagram? If I want molten lead iodide, how do I get it to be molten? I need to heat it using a Bunsen burner. So that's the one that's missing from the diagram. Clearly label the electrodes on the diagram. That means which one is positive anode and which one is negative cathode. Well, first of all, where are the electrodes? The electrodes are the ones going into the liquid. Okay, so the two electrodes going into the test tube, or the two lines going into the test tubes, these represent the electrodes. Now, which one is connected to the positive end of the battery? That would be the anode. The one connected to the negative end of the battery, that would be the cathode. Give one other expected observation. He already told me that we see purple gas, so that's one observation. Now, during electrolysis, what else will I see? Well, remember that we have a bulb. Can you see the bulb? The bulb will light up during the electrolysis, or we will see the lead metal forming, and the lead metal will be silvery metal showing through our forming during the electrolysis. So that during the electrolysis, either you say the bulb lights up or a silvery metal is formed. When the molten lead iodide cools and solidifies, remember that when it cools and solidifies, it becomes a solid. Solid ionic compound does not conduct electricity, so what happens would be the bulb goes off. Okay, so just why a stopper is not used in the top of the boiling tube? Well, how am I going to put a stopper if a gas is supposed to escape? So this allows the iodine vapors to escape. Explain the observation at the positive electrode. He said at the positive electrode we get purple vapors. Why is that? Because the iodide ions will lose electrons to form iodine, and iodine at the high temperature that we use to get all of this molten, the iodine will be a vapor. Give one safety precaution necessary. Again, when he tells you give one safety precaution, you look at the experiment. What are we doing? If we are using gases or forming gases, the main important safety precaution is do the experiment in a fume cupboard. That is the basic rule. Okay. The apparatus below was used to deposit a thin layer of chromium on a steel knife. So he's trying to cover the steel knife with chromium. So what is the name of this process when the metals are coated with other metals? That is called electroplating. Okay, so just the identity of metal A. Well, what is he trying to cover it with? Chromium. Then the metal is chromium. What would be the salt? If I'm trying to electroplate it with chromium, then the solution that we are dipping all of this in should be the solution of something chromium that is soluble. So chromium, what is soluble? We know that any nitrate is soluble, so the safest bet would be chromium nitrate. Okay. Give two reasons why steel knives are coated with chromium. Again, we said, why do we do electroplating in the first place? We said we electroplate anything, or we cover a metal with another metal in order to prevent corrosion or to give it a nicer appearance. Remember when we were saying we're going to cover the spoon with silver, we said this could be to give it a more expensive value. But with respect to chromium, chromium doesn't give it a more expensive value, so we just say to give it a nicer appearance. Okay, a concentrate solution of sodium chloride was electrolyzed using this apparatus. On the one observation noted was that the universal indicator turned purple at the negative electrode. So we did something similar to this. We said if we're doing electrolysis of concentrate sodium chloride, what is formed at the positive and what is formed at the negative? We said at the positive we will form chlorine gas, and at the negative we will form hydrogen gas. So what observation would be made at both electrodes? If gases are formed at both electrodes, then at both electrodes there will be bubbles of gas. Now, why did the indicator turn purple? Remember, we say it turns purple or it turns blue at the negative. Why? We formed hydrogen gas at the negative, but hydrogen gas is not what causes the change in the color of the indicator. The substance that causes this change is the fact that when the Cl- reacted and the H+ reacted, we are left with sodium hydroxide solution in the formed in the solution, and sodium hydroxide is alkaline, so it causes the indicator to turn purple. Name the product formed at the positive. Remember, we said at the positive we're going to form chlorine gas because this is concentrated, and we said when we're comparing between chloride ions and hydroxide ions, the one present in larger amount is the one that reacts, so it is the chloride ions that react to form chlorine. So just the effect of this product on the inverse indicator. What was the test for chlorine gas? We said if we put indicator or litmus, it bleaches. Okay, there are three products of electrolysis of concentrated sodium chloride. Hydrogen is one of them. Write an equation for the electrode reaction which forms hydrogen. Again, how is hydrogen formed? This is formed from the H plus ions, and we said if we have the sodium ions and the H plus ions, because the H plus ions are less reactive in the reactivity series, they are the ones that will react. So the H plus ions gains electrons and becomes hydrogen gas, and this is the equation that we have. H plus plus electron to give H2. Hydrogen is diatomic, so it has to be H2. That means if I'm balancing it, I have two hydrogens after the arrow, so I need two hydrogens before the arrow. That means now I have two positives, so I have to balance it with two negatives. Name the other two products of electrolysis of concentrated aqueous sodium chloride and give a use of each one. Okay, so we said in sodium, if we're doing the electrolysis, what do we get? We get hydrogen gas, and we've already talked about that. Now, what are the other two products? We said at the other end of the anode, what is formed? Chlorine. What do we use chlorine for? You should know that we use chlorine to kill bacteria in drinking water. We mentioned this in a previous chapter. So uses of chlorine to kill bacteria in drinking water or to kill bacteria in swimming pools. The other product, we said what is left in solution. I have Na plus and OH minus left in solution, so that forms sodium hydroxide. And if you remember from the chapter on organic, we said if we heat fats with sodium hydroxide, we use that to make soap. So the use of sodium hydroxide is to make soap. Okay, electricity was passed through a solution of concentrated hydrochloric acid as shown below. Bubbles are observed at both electrodes. Give one other expected observation. Since he gives you a diagram of the bulb, that circle with an X in it is a bulb. Well, the first thing that comes up to mind is the fact that if there is electric current passing through, then the bulb lights up. Label the electrodes. Where are the electrodes? The electrodes are these square things inside the test tube. So which one is the positive and which one is the negative? Well, the one that is connected to the positive end of the battery or the longer line, that would be the positive electrode, which is the anode, and the one connected to the negative end of the battery, which is a smaller line in the battery, then that would be the cathode, which is negative. Okay, name the gas given off at the cathode. Where is the cathode? The cathode is the negative electrode, and what goes to the negative is just H plus. We don't have anything else in solution, so it has to form hydrogen gas. Copper oxide is reduced to copper, which is then refined by electrolysis. The word refined means purified. So when we said purification of copper, this is the same as refining of copper. Label the diagram of the apparatus which could be used to purify copper. So we said to purify copper, we have one of these electrodes has to be pure copper and the other one has to be impure copper. Which one would be the impure copper? The impure copper is the one in which we want to cause it to react to give copper ions, while the pure copper is the one that I want my copper ions to go to so that they can deposit as copper. So again, the pure copper is the one that I can attract copper 2+ ions to it in order to form copper. So the pure copper has to be the negative electrode. The other one would be impure copper, and if we're trying to purify copper, then the solution should be a solution of copper something that is soluble. So you can either say copper sulfate or copper nitrate. Electricity was passed through a solution of concentrated hydrochloric acid using the apparatus shown. Complete the boxes to identify the parts. Of course, when he has the line going to these two square things, then both of them are what? Both of them are electrodes, and that circle with an X is the light bulb. Electricity was passed through aqueous copper sulfate using inert electrodes as shown. Copper was deposited at one of the electrodes. So name a suitable material for the electrodes. We're using what? Using inert electrodes. So the inert electrode is usually graphite, and we said if he mentions a metal that is inert, then you should say platinum. Otherwise, it's graphite. At which electrode was copper deposited? Remember that the copper ions are positive, so they will go to the negative electrode, which is the cathode. Give one other observation seen. We said again the bubbles of gas at the anode. He already mentions that the bulb has lighted up. So what is happening? We have copper sulfate ions, H plus ions, hydroxide ions. What is formed is at the anode, at the positive, the hydroxide is going to react and give oxygen, so we see bubbles of gas. The electrode at which copper was deposited was removed at intervals, washed, dried, and weighed. So just how the electrode was washed, the electrode is just like anything else. We use distilled water. Remember, the word distilled just means pure water that we use in the lab. How could the electrode be dried? Since it is a metal, we just put it in an oven. We do not need to dry it between filter papers. And he gives me a table here, and he says complete the table by calculating the total. Do you understand what is happening? He has two electrodes, and one of them is increasing in mass, which is the one to which the copper ions are going and depositing. So complete the table by calculating the total increase in mass for the remaining time intervals. What is the total increase in mass? What is he doing? The electrode at the beginning was 3.75 grams. So any total increase in mass would be the mass of the electrode minus the original. So 4.5 minus 3.75. 4.75 minus the original, which is 3.75, and so on. So this is just the mass minus the original, which is 3.75. Okay? Then he says plot the points on the grid below. You should know how to plot graphs by now using small x's or small dot with a small circle. None of them should be huge and none of them should be just dots. Okay? So when we plot these, we find that these are the points that we have. Again, be very careful when you're plotting. Notice the intervals. Notice each line represents how much, and so on. Okay, and then he says draw a graph with two intersecting straight lines. Before you join the points, please check to see if he's telling you to join them in a specific way. So here he's saying two intersecting straight lines. Usually if he doesn't mention, then it is just a curve. But here I have to do it with two intersecting straight lines. Okay? Solution of zinc sulfate is electrolyzed using inert electrodes. This electrolysis is similar to that of copper sulfate. So what I have is zinc sulfate solution, and he wants the reaction at the cathode. The cathode is the negative, so I'm looking for what is the positive ion in solution. The positive ion is either H plus or zinc ions, 2 plus. He's saying this is similar to copper. Remember, when we were comparing H plus to copper ions, we said it is the copper ions that will react. So here we're comparing it to zinc, so it is the zinc ions that will react. Complete the equation for the reaction at the positive electrode, so you need to balance this. Remember, when the hydroxide ions work, they give oxygen gas, which is diatomic, and then you balance and you find that you will need to do this. The electrolyte changes from zinc sulfate to what? Well, let's look at the ions again. The zinc ions have reacted and the hydroxide ions have reacted, so we're left with what in solution? H plus ions and sulfate ions, so that forms sulfuric acid. Describe an industrial method of making chlorine. We said, how do we make chlorine? How do we manufacture chlorine? Well, we talked about this. We said this is electrolysis of concentrated sodium chloride using graphite electrodes. So this is actually how they prepare chlorine. Describe how zinc metal can be obtained from zinc sulfate by electrolysis. A labeled diagram is acceptable. Include all the products of this electrolysis. The electrolysis is similar to that of copper to sulfate. So this is just like copper to sulfate. And I want the zinc metal at which one? The zinc metal will be at the negative electrode. So these are, he's saying, first of all, label the diagram. These are graphite electrodes. This is aqueous zinc sulfate, and the aqueous zinc sulfate will change to sulfuric acid. Now what is going to happen is that at the negative, the zinc ions go there, take up electrons and become zinc, and at the positive, it is the hydroxide ions that give electrons, and form oxygen gas. Okay, so once you've answered, check that you have given him all that is required, because he needs 4 points. So he's saying include all the products. Okay, we've said the products are zinc and oxygen, and label the diagram. What is a cell? We said, what's a cell? A cell is a device used to convert chemical energy to electrical energy. And we said, remember that in electrolysis, we're doing the opposite. Electrolysis, we're connecting it to a battery, so we're changing the electric energy into chemical energy. One of the main uses of selenium is in photoelectric cells. These cells can change light into electrical energy. Now, name a process that can change light into chemical energy. Light to chemical energy, well, that is photosynthesis. That's the one that happens in plants. Name a device which can change chemical into electrical, chemical into electrical. That's the one that we just said. It is called a cell. This is what we refer to at home as the battery that we put into whatever remotes or something. Okay. The diagram shows a cell. This is a device which produces electrical energy. The reaction in a cell is a redox reaction. If you remember what's a redox, that means one of them will have oxidation and the other will have reduction. Complete the cell. A cell will change what again? We said a cell will change chemical energy into electrical energy. Now draw an arrow on the diagram to show the direction of the electron flow. Remember, the electron flow in this cell will go from the negative electrode to the positive electrode. Okay? The electrons in a cell, remember when we were talking about electrolysis, we said the electrons will go towards the positive end of the battery, away from the negative end of the battery. Here there is no cell, so we're going from the negative electrode, because that is where the electrons are being generated, and they go towards the other electrode, which is the positive. In the left hand beaker, the color changes from brown to colorless. So what do you think is happening? It must be that the bromine, which is brown, is taking up electrons to form bromide ions, which are colorless. Okay, we're finished. Questions on electrolysis, please study the chapter and do a quiz. Okay.